Hello again. Welcome to our second part of our lecture on labor demand. Okay, so now we're going to switch over and look at the long run. Okay, in the long run, the firm maximizes profit by choosing how many workers, but now it will also choose the amount of capital. So it's choosing all inputs. So we're going to assume that there's just labor and capital, but in general, in the long run, the firm's going to maximize profit by choosing all inputs that maximize their profit. So there's going to be two components of the model. One is called isoquant curves. Okay, isoquant curves show the possible combinations of labor and capital that produce the same level of output. It's similar to an indifference curve. An indifference curve shows combinations of goods that individual would remain indifferent, but we're not talking about preferences here, we're talking about production. The second component are called isocost. Isocost lines simply indicate equally costly combinations of inputs. Let's derive the profit maximizing condition now. So we know profit equals revenue minus cost. Profit is going to be equal to price times quantity, so that's what revenue is, and quantity is a function of N and K, and then we're going to subtract cost. Cost is equal to the wage times the amount of labor we use minus the cost of capital times the amount of capital we use. The firm now would want to maximize profit subject to labor. Okay, so that's what this is. So this is the derivative of the profit function with respect to N here, which is labor, but it also wants to maximize profit with respect to capital as well. So this is our second condition here. Profit prime equals P times marginal product of capital minus R. So again, if you don't remember from last time, this Q prime N is just going to be the marginal product of labor, and here Q prime K is the marginal product of capital. Okay, so we want to set these equal to 0. Because we want to maximize profit. When we do that, we can rewrite this above so that we have the marginal product of labor, which is the Q prime N, equaling the wage over the price. Similarly, when we set this one equal to 0 and solve for the marginal product of capital, which is Q prime K, we get R divided by P. Now, we can rearrange each one to isolate P, and then we just set them equal to each other. And so this is the profit maximizing condition in the long run. Now, each of these ratios is just the cost of producing an additional unit of output. So here we have the wage divided by the marginal product of labor, and so that's the cost of producing an additional unit of output. And this is the cost of producing an additional unit of output in terms of capital. So this is for labor, this is for capital. Now, just to get some intuition as to why this is a profit maximizing condition, let's suppose that let's suppose this doesn't hold and a firm is producing at a point where the wage divided by the marginal product of labor is equal to 10 and for capital it's equal to 12. Well, if that's the case, if these two aren't equal, then this can't possibly be profit maximizing because the firm can just reduce its capital by enough to save one unit, and then they would save $12. So they would make one less unit with capital, save $12, and make one more unit with labor, and only spend 10. So they're getting the same output, but they've reduced their cost by $2. So obviously then profit would be higher. Okay, so if this doesn't hold, then one input is cheaper than the other, and so you can reduce costs by substituting the more expensive one for the cheaper one. Okay, so this is the profit maximizing condition. Now let's look at what isoquant curves are and discuss them. So here we have an isoquant curve. So this is Q0 is an isoquant curve. Every point along on this curve represents the same level of output. Okay, so we're making output with capital and employment or labor. And so every point on here represents combinations of capital and employment that will give you Q0 units of output. Okay? The input combinations at points X and Y produce the same units of output. Combinations of input bundles that lie on higher isoquants, like Q1, produce more output. So as we move in a northeasterly direction, and we have higher and higher isoquant curves represent higher and higher levels of output. The slope of a line tangent to this thing, as we'll see, measures the marginal rate of technical substitution. So here we have an isoquant, Q0. A higher isoquant, Q1, represents higher output. The slope of a line tangent to these curves exhibits a diminishing marginal rate of technical substitution. So the slope is equal to the change in K over the change in N, right? So up here, if we take away this much labor, the firm would need to use this much capital to produce the same amount of input. The slope of a line tangent to the isoquant curve measures the marginal rate of technical substitution, which is how much capital needs to be substituted for labor to keep Q constant. And we're going to have this diminishing along the isoquant, mainly because we're saying that they're not perfect substitutes. If you have a lot of capital and a little labor, that is going to give you a different marginal rate of technical substitution than if you have a lot of labor but not so much capital. If you have a lot of labor and then you use a little bit of capital, we're going to say that you only need to use a little bit because you don't have that much to keep output constant. But if you have a lot of capital, there's diminishing returns to it, so you're going to need more for any given reduction in. And we can write the marginal rate of technical substitution as negative the marginal product of labor over the marginal product of capital. Okay, there's two special cases of isoquants. One is to represent perfect substitutes. So here the isoquant is just a line. It's linear. And so this means that capital and employment are perfect substitutes. In this example, we have that capital is, so we could produce the same amount of output with 1 unit of capital or 2 units of labor. So 2 workers can always be substituted for 1 machine. Okay, so we would represent that with a line. It's linear. Now on the right we have an isoquant, which is at a 945-degree angle. So on the right we have an isoquant that represents if the inputs are perfect complements. Okay, so for example, for this good, to make Q0 units, you need 5 units of capital and 20 units of labor in exactly those quantities. So if you use more labor but don't increase capital, you're not going to get any more output. Okay, same thing. If you use more capital but don't change your level of labor, you're not going to change output. Okay, so this is perfect complements. This is what an isoquant would look like. On the left, you have what an isoquant looks like for when the inputs are perfect substitutes. Okay, now we're going to look at isocost lines. The isocost line is an indication of the labor capital bundles that exhaust a specified budget for the firm. So it is, for example, all the combinations of capital and labor that would result in a total outlay of, say, $200. Okay, so they indicate equally costly combinations of inputs. Higher isocost lines indicate higher costs. So these are what they look like. They're straight lines. So this isocost line represents all of the combinations of capital and labor that result in a cost of C0. And similarly for this isocost line, these are all the combinations of capital and labor that result in an outlay of C1. Okay, and as you move in a northeasterly direction, each cost line represents higher and higher cost. Now the slope of an isocost line is equal to, in this case, because you have labor on the horizontal axis and capital on the vertical axis, it's equal to negative W over R. So negative the ratio of the wage to the price of capital. Okay, and the intercepts are obtained by just taking the cost, the total cost, and dividing it by the cost of what's measured on this axis. So if we were to just use capital, we would take the total cost and then divide it by the price, and that'll tell us how much capital we can buy for this total cost of C0. And then similarly, we would get this point here by taking the total cost and then dividing it by the total cost of labor. That would give us this point, and then we can just draw a straight line. Okay, so these are the corner points, and anything in between shows that same cost, but using a combination of either capital or labor. Okay, so here again we see our ISO cost lines. This is a higher cost, this is a lower cost. Let's look at the formula for drawing one of these things. So we know in general that the cost, the total cost to the firm, is equal to the rental rate of capital times capital plus the wage times labor. That's our total cost. We're just using two variable inputs here, capital and labor. Now, if we want an equation that we can, say, plot in this space to get the ISO cost line, well then we would just solve this for, isolate K. So we have K equals everything on the right. And when we do that, so if we rearrange this and isolate K, we get C over R as the intercept. This is going to be the y-intercept. Labor is equal to 0. This would be the vertical intercept. So it would be C. That's why we have C divided by R here. And then we have minus this term in front of labor. And so we know this is the slope, which is wage over the rental rate of capital. Okay, so the slope is equal to negative W over R. Okay, so that's the ratio of wages, price of labor to the price of capital. Okay, so let's see what happens to the ISO cost curve if there is an increase in the wage. So let's suppose our total cost is 600, and let's think of an initial point where we have 20 units of capital, 50 units of labor. The cost of capital is $5 and the wage is $10. If that's the case, our intercepts will be as follows. The y-intercept is going to be 120 because we're taking 600 and then dividing that by 5. And then we have our x-intercept, which is 600 divided by the wage. Okay, so this would be our ISO cost line. So any point on this line represents combinations of capital and labor that end up costing $600. Okay? Now, and so these are the intercepts, 120 and 60. Now suppose the wage increases to $15. Okay, so the wage is going to increase. How is that going to affect the ISO cost line? Well, we know now if the wage increases and we were to stay at using 20 units of capital and 50 units of labor, the cost would be $850. And the intercepts would be as follows, 170, 56.7. So if we look at the equation for the ISO cost line, we can see here that total cost will increase, right? And then also we will have this increasing. So we know the slope's going to become steeper, and then we also know that the y-intercept is going to be higher. And then also we can see here that the x-intercept will decrease slightly. So this is the new ISO cost line. And they're both going through the point 2050, and that's because we're assuming, we're picking the point capital of 20 and labor of 50. And so when the wage increases, it's going to rotate the ISO cost line around this point. And again, when we do this, we're assuming that the that initial point, or a point on the initial ISO cost curve, is going to be the same. So again, capital is 20 for both, labor is 50 for both. Okay, so now let's talk about the firm's optimal combination of inputs. So we're putting together here the ISO quant and the ISO cost lines. and we're going to say that P is the optimum point. Okay, so think of a firm. It's going to choose a quantity that it wants to produce that would maximize its profit. That would be, in this case, Q0. And so it wants to produce that with minimum cost. So obviously then we would want the ISO cost, we would want to have the lowest ISO cost line that is tangent to Q0, because that's what we want to produce. We want to produce Q0, but we want to do it at the lowest cost. And remember, ISO cost lines, if you fall, if you go in the southwestern direction, the overall costs are falling, so we want the lowest one that is tangent to the ISO quant. Any other capital labor combinations would not be profit maximizing. And that's easy to see here. At point A, we can use this amount of labor and this amount of employment to produce Q0, but that's going to cost us more. That's on a higher ISO cost line. So why would we do that? We would rather produce at the cost minimizing point. So here's another example. We have our optimum point, which is E0, which is the cost minimizing choice for producing Q0. Q0 is produced in the least expensive way. No other point on the isoquant for Q0 lies closer to the origin. Again, we could produce here Q0 at this point, but we'd be on a higher ISO cost line. We would want to be here. So now, does cost minimization imply profit maximizing? Well, no, because we can pick any quantity and see what the cost minimizing combination of capital and labor is to produce that. We have the firm to profit maximize, there's only one Q, and it wants to produce that in the least costly way. So no, but profit maximization does imply cost minimization. So the firm chooses the least cost combination of capital and labor. This least choice is where the ISO cost line is tangent to the isoquant. So this is also where the marginal rate of substitution equals the ratio of input prices W over R at the least cost choice. Now let's think about what happens for a wage change. In this case, we're going to show what happens if the wage increases. What is the effect of that on labor demand? So we're initially at point E0 here. This is where we are maximizing profit. The firm is maximizing profit. Now suppose the wage changes from W0, which is what it is here. So the slope of this line is W0 divided by R0. So we're saying it increases. And so the relative cost of wages to capital is increased. So we have now a new ISO cost line. Now, the thing is, it's going to cost more now to produce Q0 with the same combination of N and K. Not only that, this point E0 now, or actually more specifically Q0, is not the profit maximizing quantity anymore. Okay, costs have increased, and so the firm will want to, it will want to produce less. Let's look at that more closely. So, a firm wants to pick the quantity that maximizes their profit. And if you remember from before, the firm is going to want to increase output as long as marginal revenue, in this case the price, is, well, they're going to want to keep producing if the price is greater than the marginal cost. And so they're going to want to produce up to the point where they're equal. So initially, if marginal cost is equal to, if marginal cost is represented by this curve here, then the firm is going to produce Q0. Okay, so they're going to take the market price, P0 is given, set it equal to marginal cost subscript 0, and they're going to produce Q0. Okay, now if marginal costs increase, and so they will if wages increase, they're going to now want to produce less. But there's also effect in the overall market. We're going to have that firms will want to produce less. Okay, so for example, if the price remained in the market at P0 and costs went up, the firm now would want to produce Q2. Okay, and now you can think a lot of firms would be doing that as well. So overall in the industry, we would have a shift to the left in the supply curve, and that's going to drive up the market price. Okay, so when all is said and done, the new quantity that the firm will produce will be where the new market price that is higher is equal to marginal cost, the new marginal cost. And so that would be in this representation at Q1. Okay, so output is going to increase for the firm, sorry, it's going to decrease from Q0 to Q1. So this is a fall in Q. So back to our diagram. Initially we were here at E0. There's our isoquant for Q0. The wage increased. Okay, but now we have a new Q that we want to minimize costs. So here Q1 is the new profit maximizing level of output, and this isocost line is the isocost line with the lowest cost, such that you can produce Q1. So the new equilibrium point is at E1. Okay, so initially we were here, we had an increase in the wage. That is going to make us want to produce less, and our new equilibrium point is represented here. So we're going to have a new Q1, and it's going to be tangent to the new isocost line. Okay, so an increase in the wage rotates the isocost line inwards. The firm will maximize profit by reducing labor and substituting capital for labor. An increase in the wage also shifts up the marginal and average cost curves. In a perfectly competitive industry, each firm reduces output and raises the price of the product. Now, if we want to derive a labor demand curve in the long run, we can. We have the information we need. So from the diagrams that we just looked at, when the wage was W0, we hired N0 amount of labor. When the wage increased to W1, we then hired N1 units of labor, which is less. And so we have our downward sloping labor supply curve. Okay, let's talk about the substitution and scale effects. Okay, so when you have a wage change, there's going to be the substitution and scale effect. The substitution effect is just simply the fact that firms would substitute cheaper inputs for the more expensive labor. So if the wage increases, that makes labor relatively more expensive than capital, assuming the price of capital stays the same. So simply put, the substitution effect means, if we're just looking at the substitution effect and holding the scale effect constant, to maximize, firms would substitute away from labor to capital, away from labor and then use capital to replace labor. Now the scale effect is the change in the quantity. So remember, when there's a change in the wage, that affects the overall costs to the firm, and so their profit maximizing level of output is going to change. Okay, so they're going to reduce their scale of operations because of an increase in the wage. So suppose there's a wage drop. The scale effect then would basically say this: the firm would take advantage of the lower price by substituting, the lower price of labor by expanding production. Sorry, this is the scale effect. And so the scale effect would mean that you can think of the marginal cost curve that we looked at earlier falling, and so the point where price equals marginal cost is going to be at a higher level of output. The substitution effect, on the other hand here, would say the firm should take advantage of the wage drop by rearranging its mix of inputs and employing more labor and less of other inputs, even if holding output constant. So the substitution effect is saying we have labor that, labor is cheaper now, we should buy more of it. Okay, so let's look at an example where we have a wage increase, and we're going to isolate the substitution and income effect. Okay, so initially we're at point E0, producing Q0. Then we have a wage increase, and so the ISO cost line is going to rotate, and the wage is going to be higher, so the slope is going to be steeper. Okay, the firm is now going to want to produce a different quantity to maximize profits. This quantity will be Q1. If you remember now, since costs increase, the profit maximizing firm would produce less Q. So the price equals marginal cost condition will be at a lower quantity level. Okay, and so the firm's going to want to produce Q1, and in order for it to be profit maximizing, we would have to have costs being minimized, and so the new ISO cost line would be just tangent to it at this point here. So this would be the new equilibrium. Now, to isolate the scale effect and the substitution effect, we need to take the ISO cost line and move it up to the old isoquant. Okay? Because here at this point, if you think of comparing this point to this point, the only difference here is the wage. Okay? And that's the substitution effect. Okay? So in fact, remember, if you remember, the slope of this line is W divided by R. So it's the relative wage. Okay, and so the relative cost of labor has increased because the wage increased, but the price of capital R stayed the same. So this decrease from N0 to NS is the substitution effect. Okay, so just because of the relative wage change, not holding the scale effect constant, this is how much the firm would change the amount of employment they would hire. So it would fall. And so now we know that the scale effect then is the remainder, which is from E1 to this point. So it's going to be from NS to N1. But this is moving in the right direction, right? So what is the scale effect? Well, the scale effect now is just the difference between here and here. Okay? So the scale effect brings us from NS to N1. So the overall effect is from N0 to N1. That's the reduction in the amount of labor as a result of that wage increase. And this portion is because of the substitution effect, and this portion is because of the scale effect. And of course, they're going to both move in the same direction. You have that labor is more expensive, so firms are going to substitute away from it. That's going to reduce the amount of labor hired, and since overall costs are increasing, the firm is going to want to produce less, and so the scale effect is also moving in that direction. In theory, there's going to be some differences between the short run demand curve and long run demand curve. In the short run, there's less opportunities for the firm to be able to substitute for a particular input. So a way to understand this is to consider, for example, an increase in the wage. Well, in the short run, the firm might have some opportunities to substitute, but in the long run, surely there's going to be much more opportunities to substitute away from labor. So for any particular input, there's going to be less opportunities to be able to change your inputs or substitute away from the input that has increased. But in the long run, there's going to be more opportunity for you to do that. And so the demand curve in the long run is going to be more elastic. Okay, now let's talk about the own wage elasticity of labor demand. This measures the responsiveness of the quantity of labor demanded to the wage rate. And it's simply equal to the percentage change in the amount of labor, the quantity of labor demanded, divided by the percentage change in the wage. Okay, so the Greek letter here, eta, represents elasticity. I denotes the category of labor. For example, if eta is equal to -3, that would suggest that a 1% increase in the wage would result in a 3% decrease in the quantity of labor demanded. Now, if we think about the labor demand curve and think about ones that are steep and ones that are flat, we can really illustrate the difference between the two. So D1 here is a flat labor demand curve. D2 is steeper. Okay, now what we're going to do is look at the effects of fixed change in the wage on both. Okay, so we're going to have a change in the wage of this distance here between W and W prime. Now, if we look at the flat curve, how much does labor change? Well, if the wage increases from W to W prime, the amount of employment is going to change from N1 to N1 prime. So it's going to fall quite substantially. If we have a steep labor demand curve, of course, the amount of employment won't change as much for that same given change in the wage. Okay? So the steeper the labor demand curve, the less responsive the firm will be to changes in the wage. And the other way around if the labor demand curve is flatter. Okay, so there's some overall laws of derived demand that we should go over. So other things equal, our eta, which is our elasticity of labor demand, is going to be high. Okay, so the firms will be sensitive to changes in the wages when price elasticity of demand for the output good is high. 2, other factors of production can be easily substituted for labor. 3, the supply of other factors of production is highly elastic. And 4, the cost of employing labor is a large share of total production costs. Okay, so let's look at these in more detail. So for the first law, we're saying that the own wage elasticity of demand is relatively high when the price elasticity of demand for the final product is relatively high. Well, this is easy to conceptualize. If the demand for the product is elastic and so the consumers are very sensitive, then any changes in the price will result, say an increase in the price will result in a lot of people doing without that product, and so the quantity demanded for the product will fall. If there's less quantity demanded for the product, there's going to be, the firm's going to want to produce less and it's going to need less labor. So the more elastic it is, the product demand, the more elastic the demand for labor will be. So this works through the scale effect. So suppose there's an increase in the wage. So we have higher wages. That's going to increase our average and marginal costs. Okay. And so that means the firm's going to, you can think of the marginal cost curve shifting up as we saw before. So the firm is now going to want to, higher costs are going to result in a higher product price. And we saw this before when we saw the marginal cost curve shift up. These higher prices then are going to result in a reduction in the quantity of the product demanded. So this is where this is key. So if the demand for the product is elastic, then these higher prices are going to have a greater impact on how much the consumers are going to buy. So if it's elastic, they're going to buy much less than if it was inelastic. Okay, and so this reduction in sales is going to result in a reduction in output. So if the product demand is inelastic, you could think of life-saving medicine or something like that, then any increases in the price as a result of higher wages isn't going to have that much of an impact, because the demand in the product market isn't going to change all that much, very little. So there's going to be no reason for the demand for labor that's being used to produce it to change all that much either. Okay, the second law, own wage elasticity of labor will be relatively high when it is relatively easy to substitute other factors for this category of labor. So this is very straightforward. This is just the substitution effect. If it is cheaper to substitute, if it is relatively easy to substitute other factors, other inputs for labor, then if there's an increase in the wage, we're going to see a lot more of substitution going on than if things were the opposite. So this is just the substitution. Now, the third law, this is saying that the own wage elasticity of labor demand is relatively high when the price elasticity of supply is relatively high for other factors of production. And this law works through the substitution effect. Okay, so what does that mean? Let's suppose the firm buys more capital because it's substituting away from labor. Well, if the supply of capital is elastic, like in this first diagram, then if all the firms now are substituting away from labor and buying capital, the price of capital isn't going to change that much. It's going to increase only a little bit. Okay, so this price isn't changing that much. But if the supply was inelastic for capital, then a lot of firms substituting away from labor and buying capital will drive up its price, and so it'll reduce the amount of capital that they would actually want to buy. Okay, so if other inputs, if their supply is really elastic, then the more it is elastic, the more the own wage elasticity for labor demand, our ETA, will be elastic as well. The last law is saying that own wage elasticity is relatively large when this category of labor accounts for a relatively large share of total costs. Well, this is kind of straightforward, and it works through the scale effect. So this is similar to what we had before. Here we're just pointing out the fact that if wages are a large portion of a firm's overall costs, then an increase in the wage is going to have a large impact. In other words, it's going to increase their costs a lot, so their marginal cost curves are shifting a lot, and so the scale effect then would make them, would result in them producing a lot less. Okay, so let's do some practice questions. Let's consider a firm for which production depends on two normal inputs, labor and capital, and prices W and R respectively. So let's say initially the firm faces market prices of labor equal to $6, so the wage is $6, and the price of capital is $4, then the prices fall to wage is equal to 4 and price of capital is equal to 4. Okay, so they both fall by $2. Now the question is, in which direction will the substitution effect change the firm's employment and capital stock? The next question is, in which direction will the scale effect change the firm's employment and capital stock? And lastly, can we say conclusively whether the firm will use more or less labor or more or less capital? Okay, well, let's think about this. So one thing to think about immediately when you're thinking of the substitution effect is, did the relative wages change? So did the ratio of wage to capital increase or decrease? Well, in this case it increased in absolute value. So the slope of the isocost line, the absolute value, which is W over R, was 1.5 before, when we had the initial prices of 6 and 4. So here we had 6 divided by 4. Now we have 4 divided by 2. So they've increased from 1.5 to 2. So labor has become relatively more expensive than capital. So holding constant the scale effect, then we would expect the firm to want to substitute away from labor and towards capital. So here we have L falling, capital increasing. Now B asks us about the scale effect. Well, in this case, we have two prices have fallen and their input prices. So all that's going on here is that you have a shift in the, the marginal cost curve is shifting down. Costs are cheaper. And so in terms of the scale effect, the firm's going to want to produce more. And to produce more, it's going to need more of these inputs. And so both the labor and capital, the quantity demanded for them would increase. Okay, so in A we have labor would fall. In B we have labor would increase. In both we have capital increasing. And so that leads into the answer for C. It's saying, can we say conclusively whether the firm will use more or less labor? Well, no, we can't, because the scale and substitution effect are working in the opposite direction. We would actually need to know specifics about the firm's cost structure and cost structure. We would need to know specifics about the firm's cost structure. And capital, for sure we can say that it will increase. Next question. Suppose there are two inputs to the production function, labor and capital. That's what we've been doing all along. And these two inputs are perfect substitutes. Okay, so if you remember, that is the linear isoquants. That's one of the special cases we looked at earlier. Now, the existing technology permits one machine to do the work of 3 workers. The firm wants to produce 100 units of output. And suppose the price of capital is $750 per machine per week. So now it's saying, what combination of inputs will the firm use if the weekly salary of each worker is $300? In B, same question, but the wage is $225. And C is asking us, what is the elasticity of labor demand as the wage falls from 300 to 225? Let's think about this intuitively. The existing technology permits one machine to do the work of 3 workers. So would it make sense to use 3 workers to produce a unit of output if they cost more than using the machine? No. So in A, we have that the combination, so we have that the wage is 300, and so if we use 3 workers to make 1 unit, it's going to cost $900. But why would we do that when we can only pay $750 and use the machine? Okay, let's look at this on a diagram. So we have a isoquant here. This is for 100 units as they mentioned in the question. Okay, so we have that the slope of this is going to be 1/3. Okay, so it's the marginal product of labor divided by the marginal product of capital, and in this case it's always 1:3, so it's a straight line, it's linear because one machine always can do the work of 3 workers, so you always have that trade-off. So we know the slope of the ISO cost line because we're told the relative prices. So in A, when the wage is 300, the slope of the ISO cost line is equal to -0.4, which is the 300 divided by the 750. Okay, now this slope in absolute value is greater than the isoquant. Okay, so here is the ISO cost line, or a ISO cost line. This has a slope of -0.4, and so in order to produce 100 units, we want the minimum cost. So we're simply just going to pull that back until, and you know, we want the lowest ISO cost line but still be tangent to the isoquant. And so that would be here at point A. And so that's telling us that the smallest ISO cost line that achieves 100 units of output when the wage is 300 is going to be at point A. Okay, so we're only going to use capital. Okay, so in this case we would use 100 units of capital. So if the slope, an absolute value of the isoquant, is greater than 1/3, we're always going to just use capital, and that makes sense. As we said earlier, if it costs more to hire 3 units of labor than it does for a unit of capital, why would you use the labor? Okay, so clearly that's what's going on here. Now in B, it says, well, what if the wage is 225? Well, then if the wage is 225, then the slope of the ISO cost line will be 0.3. So that's lower in absolute value than 1/3. Okay, and so then it is cheaper now to just use 3 workers than it is to buy a unit of capital. And so we have our new ISO cost, an ISO cost line, in order to find the cost minimizing amount of capital or labor to produce 100 units. We take the ISO cost line and pull it down until it becomes tangent to the isoquant. So we want to pull it down and find the lowest ISO cost line that is still tangent to the isoquant, so we can still make the 100 units. And we see in this case it's going to be at B, so we're only going to use labor. Okay, so with this type of isoquant, it's always going to be an either or. If they're exactly equal, the slopes of the two, then you can sort of, you could pick any point. But you know, for most cases, it's either going to be one point or the other. Okay, next, so here is just an explanation of the solution that we went through. Just to finish up, the elasticity of labor demand. So remember, it asked about the elasticity in part C. Well, the elasticity of labor demand is obviously the percentage change in the quantity demanded of labor divided by the percentage change in the wage. So what did we have here? So we have that the wage change, so we can calculate a percentage change in the wage, but in terms of the percentage change in the amount of labor, well, we went from a positive amount to a negative amount. Here, the demand for labor goes from 0 to a positive quantity when the wage drops to 225. So in terms of a percentage change there, that would be actually infinite, okay, because we would have the percentage change in labor being, if you remember your percentage change formula, it would be 225 minus 0 divided by 0. So something divided by 0 we say is infinite. Okay, so next class we're going to be combining labor supply and labor demand and looking at the overall labor market equilibrium. Thanks for listening, and we'll see you next time.